Welcome back. Today, we're going to be talking about hypothesis testing and doing a question regarding interpreting p-values. This is a preparation question for the AP Statistics exam. All right, so the question says that a pharmaceutical company is testing a new drug for treating high blood pressure, and a large scale clinical trial is conducted to evaluate the risk of a severe allergic reaction. And the hypotheses are tested. So we have the null hypothesis, which is that the proportion of the population who will have a severe allergic reaction to this new drug is going to be 0.0002. And the alternate hypothesis is that it's going to be more than that number. Now, the first question asks us to interpret the p-value in the context of the study. So, in other words, like what does it mean if we have a lower p-value versus a higher p-value in the context of the question? So, basically, a smaller p-value means that it's really unlikely that if the null hypothesis were true, that what occurred in the study, which we don't know, it didn't actually tell us, but that whatever occurred in the study was likely to happen, right? It means it's not very likely to have happened. And so, in that scenario, it's usually pretty safe to reject the null hypothesis. Now, of course, it's not guaranteed. We're not going to get zero as our probability, but typically, if we get less than 5%, generally we're able to reject that null hypothesis and say that that's not going to be the case, right? Whereas, let's say we get a high p-value, right? That tells us that there is a larger probability that we could end up with the results that we ended up with, given that the null hypothesis is true, in which case we will fail to reject the null hypothesis. That doesn't mean we're going to accept the null hypothesis as true. It's just saying that based on the data collected, based on the information given, we aren't able to reject the null hypothesis because there isn't enough evidence based on what was collected that the null hypothesis is untrue. It still could be untrue, or it still could be true. We don't really know. But that's what we mean by, by interpret the p-value, right? What does the p-value mean? Long story short, it's the probability that if the null hypothesis actually is the genuine case, that the results of the study would actually happen. So if it's like, oh well, that's those results of the study were super unlikely to happen, given that this was the actual number, we could say, well, maybe then it's not the actual number, right? Perhaps we should reject. Okay, the next one says, what would the conclusion be um, at the 0.05 significance level? I think this word trans is just there by mistake. We'll cross that out. But anywho, let's talk about what the conclusion should be in this scenario. Okay, so how can we decide what conclusion should be made at the 0.05 significance level? Well, the 0.05 significance level, this basically means that if the p-value is greater than 5%, or 0.05, then we would fail to reject the null hypothesis. Now, the null hypothesis could still be false, but there just isn't enough information if we need to be this sure about it to be this sure against it in order to actually get rid of it. Whereas if we have a p-value less than 0.05, we can reject the null hypothesis because there is significant evidence at that point that the proportion is greater than 0.00002. And so that's essentially what we can say here, right? If p-value is less than 0.05, we can reject the null, so reject HO. And then if the p-value is greater than or equal to this, then we would fail to reject, just because even though we can't necessarily accept the null and say that that must be the case, basically we just don't have enough evidence to reject it. So we would fail to reject the null hypothesis based on the information given. Okay, so that's part B. And then part C says, based on your conclusion in B, what type of error may have been committed and what is a possible consequence of this error? Okay, so there's two types of errors that can possibly be committed. The type 1 error is essentially a false positive. So a type 1 error, I'm going to write that down. And this could have possibly been committed if we rejected the null hypothesis, even though the null hypothesis is true. So basically, if we falsely rejected the null hypothesis. And although this isn't likely, and that's why we're doing this test, it is still technically possible, right? What if the results were had less than a 5% chance of occurring, but they still did occur, right? They could still potentially occur sometimes. And so, therefore, we would have committed a type 1 error, falsely rejecting the null hypothesis and assuming that the proportion of people with severe allergic reactions is actually greater than it is. And in this context, the consequence of that is because the drug might be incorrectly thought of as having a higher risk to people who are prone to severe allergic reactions or who've reacted badly to previous medications. And so there could be extra warnings, there could be extra, times when maybe it would have been the best decision for a patient, but maybe it perhaps was not something suggested to a patient when it otherwise could have been because that patient had some sort of medical history that caused the doctor to decide to not suggest it based on the risks, things like that. And so those could be the potential consequences of rejecting the null hypothesis when the null hypothesis actually was the case. Now, is that likely to happen? Is it likely that we committed that error? Probably not. It's not too likely, right? However, it is still possible and it's still something we should consider. Okay, let's talk about the other error that might have occurred, and that's a type 2 error. And that's if we fail to rejected the null hypothesis, even if it should have been rejected in the sense that it's false, right? So let's say that HO null hypothesis is false, but we failed to reject, right? Because as I mentioned earlier, it is very possible that that the reason that we fail to reject isn't because the null hypothesis is true. It's not always true necessarily. Sometimes the reason we might fail to reject is just because, well, it wasn't that, what just wasn't quite unlikely enough to reject the null hypothesis. And so basically, in that case, a type 2 error may have been committed. And that means that we failed to detect that the allergy risk is actually greater than 0.002, right? We failed to detect that that is the case. And so the consequences of that could be that the drug might be approved at higher rates than it should be, or people might not necessarily know the true risks of it in that particular situation. And so the thing is, either we could make this value 0.05 a different value in order to be more picky. But the thing is, the pickier we are, then the more likely we are to have the other type of error, right? So it's kind of a double-edged sword of which consequences would we rather have. Would we rather be too cautious and assume that the drug is potentially more dangerous than it actually is, or would it be better to underestimate the drug, right? So which poison do we want to pick essentially? Now, in this particular context, probably, I mean, we don't really want any error, of course, but we'd probably rather have a type 1 error than a type 2 error because a type 1 error basically is more alarm bells, false alarms about potential risks that aren't really there. And that isn't great, but that is better than the idea of potentially overlooking an actual genuine danger and giving people this drug who might be more likely, based on their history of other drugs or things like that, who might be more likely to have that severe allergic reaction and could be in danger because of it. Now, as always, feel free to leave any questions you might have in the comment section, and we'll see you for the next one.